So today we're going to talk about the product rule for exponents, which just means what do you do with the exponents when you multiply? That's what we're going to talk about today. All right? So let's just begin. Rather than talking about what do we do when we have variables, let's just start with numbers. So let's just start with something really simple, like 3 times 3. Now, I know you guys all know 3 times 3 is 9, but can we write it with an exponent rather than saying 9? Mm-hmm. So, all right, 3 squared. I don't know if you noticed there, but this has an exponent and this has an exponent, and you added them together when you multiplied. If there's something like this, what do you think you get? You added up the exponents when you multiplied. Now you're probably not thinking of it that way. You're probably just thinking, oh, there's 4 or 3 4s multiplied together, so 4 to the 3rd power. But if we have something like this, okay, so we end up with 5 to what power? The 5th power. And I want this to make sense to you, so remember that 5 squared is simply 5 times 5 times 5 cubed, which is 5 times 5 times 5, and that's 5 to the 5th power. That's 5 5s multiplied together. We add the exponents up when we multiply. That's the whole thing. That is the product rule for exponents. Now we're going to do, some bigger ones, I suppose. P to the 5th times P to the 17th. Yeah, but what do you do with the exponents when you multiply? Yeah, you add them. That's P to the 22nd power. That's it. That's the whole thing. Okay? So your job is going to be looking at some products, and the products are going to look like this. So you're going to have a bunch of variables multiplied together. And I want to make something clear. This is one term. Do you understand? Here, let's count the terms. Ready? Everyone ready? Let's count the terms. 1. Very good. One term. It's all one term because it's all multiplication, isn't it? Okay, now if it said something like x squared, y squared, plus x to the 5th, y to the 3rd. Now how many terms do we have? 1. Let's count them. 1, 2. 2 terms. So the addition kind of breaks it apart, doesn't it? But down here we just have one term. It's all multiply. And does it matter what order we do multiplication in? Doesn't, does it? So it's okay to multiply these two x's together. What does that give me? X to the? 7. Okay. And it's okay to multiply the two y's together. Y to the? Yeah. That's it. You made it a little simpler. That's your whole job. That's all you're worried about. Dane, are you paying attention? Really? Okay. This thing's killing me. This mask is not staying on.
I need some of that. I think he wants you to.
You need some of that too?
Yeah.
Here.
I think they just want you to take them all.
Oh, yeah. Just tape that baby on your nose. It'll stay up. Okay, let's look at a little bigger one. Hey, the girl who brings you money. Awesome. Okay, so first of all, let's count the terms. Ready? Count with me. 1. Good job, everybody. Okay, now I'm going to... Yeah?
Did you get your money?
Yeah. Amazing.
What they did mine for volleyball.
What'd you get?
I did football.
Oh. As long as it's money.
I think they pay less though.
Money don't come from.
Okay.
I'll take it.
So, I'm going to go through in alphabetical order. You don't have to, but I usually start and I'll multiply the m's together. And you have to be a little careful here because you have to remember that this m has an exponent, right? Okay, it's not m to the 0. If it were m to the 0, that would be a whole nother thing to deal with. So we just have m to the 3, 4, 5, 6, and then p to the 1, 2, and then x to the 1, 4, and there you have it. That's all there is to it.
Wait, why is there only m to the 6? Oh, I see it now. I thought that x was that m to 7.
Okay. All right. So, that's pretty much it. You don't have to do anything else. You just write it in a simpler way. So I'd like you to try one. Ready? Here you go. Simplify this expression. Don't write down the original problem. Just simplify it. Right, Gracie? I thought I was right. You done? Okay, so we have x to the 4th and y to the 3rd. That's it. You did it. Now, does anybody have it in the opposite order? If you do, you're still right, aren't you? It doesn't matter what order the factors come in. So that's it. That's all there is to it. Now, that's the easy part of the lesson. Here's the hard part of the lesson. And it's easy too. It's just keeping them straight. So we've been adding like terms. 2x plus 5x equals 7x. Okay. It does not equal 7x squared, does it? Okay, it's not x squared because we're not multiplying these two x's together. So when we add like terms, our answer has to be a like term.
Yeah.
And I want you to notice that these have exponents, don't they? Okay, they do have exponents, and they remain the same when we add the like terms. The exponents don't do anything because we're not multiplying. All right? So you haven't been given anything where the exponents weren't 1. You haven't been given a problem like this yet, have you?
I had one like that on Alex,
Okay, good.
and I got it
So,
right.
okay, good. So when we add terms, by the way, should we count the terms? Let's count them together. Ready?
1, 2.
Very good. And are they like terms?
Yeah.
Their literal coefficients are the same, aren't they? They're both x squared. So we can add them together and just say 5x what? Squared. And this is the thing that'll get you. You start adding those exponents up when you're multiplying, and then when you do the like terms, you want to add the exponents together. Okay, but you've got to remember you only add the exponents when you're multiplying. When you're adding like terms, the exponents have to stay the same, and your answer has got to be a like term. Yes?
What would you do if the exponents were different?
Okay, what would we do? So let's say we had something like this. Okay? So when you look at those two, they are not like terms. Even though they both have an x, okay, this one's x squared, this one's x, they're not the same. So you can't combine them, and that would be the answer. That's as far as you would get. So let me show you why. Let's say I had 5 times 3 plus 4 times 3. Well, that's 9 times 3, isn't it? I'm letting you think. This is the whole idea of adding like terms. Their literal coefficients are the same, aren't they? Just like 5x plus 4x is got to equal 9 times x. 4 times a number plus 5 times a number is 9 times that same number. But what if I had 5 times 3 plus 4 times 9? Are they like terms? See how they're times a different thing? Well, you couldn't put those two together and say, well, that's 9 times 3, or 9 times 9, or heaven forbid, 9 times 27. That wouldn't be the same thing, would it? Okay? And if you were to take 5x plus 4x squared, isn't that kind of the situation we have here? This is 3 and this is 3 squared, right? And I have kids give me this answer all the time. 9x to the third power. And what they're doing is they're adding these exponents. But that would be the same as saying 9 times 27. And that is not even close to correct, is it? That doesn't work. So the easy part is when we multiply, we add the exponents. Okay? And here's what the rule looks like. X to the n power times x to the m power is equal to x to the n plus m power. Now, you've probably never seen exponents that look like that before, have you? But isn't that the rule? Isn't that what's going on? I see a little bit of nodding. Can I have a yes?
Yes.
All right. Okay. And then when we're adding like terms, if we have x to some power, 5x to some power plus 4x to the same power, we can put them together, but the answer has got to be a like term. If you're adding and your answer is not a like term, okay, then you're not doing it right. So, get your paper where you're going to do set 21 where you took your notes and stuff today. Okay? So I just want you to simplify this expression. You don't need to write down the original problem. All right? X to the 8.
Y to the 6.
Yeah, I got it right.
That's it. That's all there is to it.
If you got that one right, you get an A+ in this class.
For the seconds from when I wrote this down to when we asked the question, you had an A+ in that area during that time.
So what you're saying is now I don't?
Wouldn't you put like numbers in front of them because there's 3x?
Well, let's remember, how many terms do we have here? Let's count it. Ready? Hey, let's count the terms. Ready? 1. Right? 1 term. And is there a numerical coefficient in front? There absolutely is. Even though I'm too lazy to write it, there's a 1 there. And is there a 1 in front of this one? Yeah, there is. Okay? Let's take a look at another one. So we have x. Say it again.
So if there's a 1 in front of every x, then why don't you add them up like you did with the x one?
We're multiplying. So if I have 1 times x times 1 times x, well, what's 1 times 1? 1. And what's x times x?
Alright.
Right?
I get that.
So that 1's not going to change because the multiplicative identity, when we multiply by 1, we get the same thing, don't we? So how many terms do we have here? 1. 1 term. And what's the numerical coefficient? 1. Very good. There's a lot of 1's going on. So x to the what? 11th, and then y to the, and m to the second. Now, normally I will put this in alphabetical order. You'll see why as we get going a little bit more, but you don't have to. That's it.
Why is it m to the second?
Because m to the first times m to the first is m to the second. So these do have exponents, even though we haven't written them. There's a 1. They are to the first power. So you guys, when I write down an a, when I write this number right there, and that is a number. We're in math. This isn't a letter. It's a number. You always have to remember that it does have a numerical coefficient, 1, and it does have an exponent. What is its exponent? 1. We're just too lazy to write them. But you certainly can write them. Okay? All right, now, the second type of problem. So if any of these are like terms, I'd like you to put them together. Write this in a simpler way. Okay, so how many terms are there? 4? Okay, so we have 1, 2, 3, 4 terms. And are they all like terms or just some of them?
Some of them.
So I'm looking at the first term and the third term. What do you think? Now they're not in the same order. This one's x squared y cubed, this one's y cubed x squared. But does it matter? Does the order matter when we multiply? It doesn't. So these two are like terms. And so we're going to put the 2 and the negative 8 together. That's negative 6. And what's the literal coefficient going to be? X squared, y cubed. And we're not adding the exponents now, are we? We're not multiplying these two terms together. We're adding them together. So that's it. And then what about the second and the fourth term? So what's the literal coefficient right here? 1. Good. So I take 1 and negative 5. That's negative 4 times xy times x times y.
But wouldn't you like, so 2x squared times y is there? Wouldn't you times those before you put those two together and they still be the same? So you just have like x, y.
Well, see, I'm just taking this whole term right here and adding it to that whole term right there.
No, like the 2.
Yeah, this one?
Yeah.
Well, I took the 2 and the negative 8 and put them together for negative 6. Because this one's x squared y cubed and this one's x squared y cubed. So because they were like terms, I just put the numerical coefficients together, and then it's times x squared y cubed.
This is a lot more confusing than I thought it would be.
It's not as bad. It's not as bad. You're going to do it a couple more times, and you're going to go, oh, all right. Okay, let's try this one. Now be careful. Look carefully at this one. So are any of these like terms? Which ones?
The first and second.
The first and the second term. So
Yes.
the first and the second term are like terms, aren't they? It would be nice if they would have written this one in alphabetical order too. It would be a lot easier to tell that they're like terms, wouldn't it? I mean, that really helps. But so they are like terms. So now tell me about the numerical coefficients of each one. What do we have here? 1. Okay. So they're like terms. I add them together. 1 plus 1, that's 2. 2x to the 6th y. And we're not going to add the exponents because we're not multiplying. We're adding, right? So this is what you got to remember. When you add like terms, your answer has to be a like term. Now what about these other two?
No.
No? So what are we going to do with them? That's it. So we made this expression a little simpler. That was our job. Okay, so look at set number 21. I want you to go and I want you to do 8, 9, 10, and 11. I'm going to give you about 2 minutes. 8, 9, 10, and 11. It will literally take you 2 minutes. Ouch.
Oh, you ripped your hoodie.
I know.
Okay. If you're not quite done, that's okay. We're going to do them together here. So, one thing I want to point out here, each of these is a single term, correct? And each of them has a numerical coefficient of 1, which we are too lazy to write. All agreed? Okay. So, it's all multiplication, so I'm just going to multiply the x's together. So we got 2, 5, 6, x to the 6th, and then y to the 1, 2, 3, 4, and that's all there is to it. And if you'd like to put the 1 there, you may. Okay? You understand? Over here, I'm going to multiply the m's together first. I believe that gives me m to the 6th, and then the x's give me x to the 5th. And if you want to put the 1 there, you can. That's it. These aren't that hard, are they? Okay. Down here, k to the first times k to the third times k to the second, that's k to the sixth. And then the y's, we have 2 and 5, that's 7. So that's it. We've simplified it. You understand? We're not solving anything, we're just writing it in the simplest way. Over here, a to the 2, 4, 5. You're not forgetting this one, are you? Not forgetting the exponent we're too lazy to write. And then b to the 1, 4, 8. That's it. Questions? Okay, now 12, 13, 14, and 15. I'll give you a couple minutes to do those.
What did you say?
12, 13, 14, and 15.
Oh, sorry.
Yeah, that is bad.
Now remember, on these you're not multiplying, so don't be adding exponents. I did not leave myself enough room. Plus 8. There we go. Hey, Tappy, stop with the tap dancing back there, huh?
You're talking about me?
I don't know. Whoever's back there tap dancing.
Were you talking about this last time?
Are you the one with the giant feet tapping them on the ground?
Yeah, I think that was me.
Yeah, quit it already!
Hey, now it's not me anymore. Now someone's trying to set me up.
What are you talking about, dude?
Bless you.
Kylie. Yeah. Okay, let's take a look. So number 12. At first I thought there were no like terms, but then I looked a little closer, and I think that the first and the third term are like terms, aren't they?
That's what I was saying.
They're both x, y, z, aren't they? And so I can put those together and say 5 x, y, z. And then this middle term, it's not a like term. It doesn't go with anything, so I'm just going to list it down. And there's a simpler way to write the expression. You don't need to write down the original problem on these or anything like that. You can just write that down. This one, sorry, didn't fit. Aren't the 7 and the 8 like terms? Right, their literal coefficients are nothing really, aren't they? So we can put those two together and say 15. Negative 3k and negative 2k, that's negative 5 times k. That takes care of those two. And I believe these are like terms as well, aren't they? They're both k times x. So we have a 2 and we have a negative 1. So that's positive 1 k times x. And it's okay to put the 1 there, especially right now, when you guys are still learning. Alright, so 14. I think the first term and the third term are like terms. You guys agree? Okay. So, now I have a little question for you. Look. Is this 3 subtract 5, or is the subtraction symbol only for the 2? Right, it has nothing to do with the 5 over here, does it? So this is a positive 3 and a positive 5, so 8 ab squared, and then I believe those two are like terms. We have negative 2 and negative 1, so negative 3 ab. Yes?
So you're adding the exponent spot to be in the same spot?
They're both on that.
Oh, okay. Never mind.
Okay. Over here, I think that x squared is all by its lonesome. Don't you guys? You agree? So that takes care of that one. And then I've got this xy. So negative 3 and negative 2 is negative 5, plus 1, that's negative 4xy. And the 2x squared y, that's its own thing, and I'm going to put them in alphabetical order all the time. You guys will see why as we go along. Now, on all these 8 problems that we did, and 16, 17, and 18, I don't think there's any work to show. It's just write it down, isn't it? But when you get to 19, I had better see on your paper what's going on, that you're replacing every variable with a parenthesis, like this, that you're putting negative 3 in for a, and you're putting 4 in for x, and then I better see, oh, well, this is negative 7, and this is positive 7, isn't it? And then the result is negative 49. And if I don't see all of this, and you don't work it down the paper, I'm putting your assignment in the garbage tomorrow and giving you a 0. Does everyone understand that? Okay, there's plenty of problems. You can just write down the answer. But on the ones where you need to show your work, where I need to show the work to get the correct answer, you better show that work, or I'm not giving you credit. Okay? Do it. Let's finish up set number 21. I don't care. You can do them in any order that makes you happy.
Wait, do you want us to do like one?
Yeah, do them all. Yeah.
Okay.
Was that a boo?
It sounds like you're moving.